Hi, and welcome back again. This is the second class, and in this class, we're going to talk about pointers. We're going to define what the pointer is, how to use it, how to manipulate pointers in C. So in this class, we're going to talk about first the computer memory. What's computer memory, how to use it, and how we store data in the computer memory. And then after that, we're going to introduce the concept of pointers. Okay, let's see. Computer memory. As we all know, the computer inside it has a microprocessor chip. This microprocessor actually makes all the operations, performs all tasks you give to. And now these operations are definitely going to be operated on data. That data is stored in what's so-called memory. The memory actually is a huge array, consecutive entries in that array, and they're numbered. These numbers are what's so-called memory addresses. And these addresses point to locations in the memory. We call them memory cells. Actually, the memory cell in most typical computers is considered as an 8-bit unit. And this 8-bit unit is called a byte. So the byte is an entry in the memory that's addressed by an address to that memory in that big, huge array. An address of a memory cell is a number, actually, which defines the index of that byte or that location in the memory. And that means whatever I store in the memory is my actual data, and to refer to that data, I use another number. That number is actually the address of that byte or that data stored in that memory. These memory cells are contiguous. That means they come after each other in like a stack fashion. However, I can access any location in the memory randomly. That means if I want to go to the location number 100 in the memory, then I can go directly to that location without going through the 0 to the 99 addresses first and then access that 100 location. I can go back and forth the way I like. So it's called a random access memory, or for short, a RAM. Here's a picture of a typical memory in the computer. It's a big stack like this. Each location is actually a byte. Each location is tagged with a what's so-called address or an index. So for example, in here, this location is pointed by this address, 112300, and this is the next location, 11230102, and so forth. So these addresses are contiguous, actually, one after each other. And then whatever I store in here actually is my data. Now my data could be by nature a 1 byte long, like a character, or could be more like an integer. An integer could take 2 bytes or even 4 bytes. Depends if I'm defining in C a short integer or an integer, or I could have a floating point number, a real number. In that case, it takes more bytes. Let's see some examples in here. For example, these two locations, 2 bytes, are reserved for the variable named x of type short, right? So for example, I want to store in this reserved location, which occupies the addresses 112300, 112301, I want to put 100 in there. So 100 is the value of the variable x. And where that value is stored, actually it's in the memory at these two consecutive locations. So address 112300, 112301 actually contains my data, the 100. Now, how this 100 is physically stored in these two locations, this depends upon the architecture of the computer system, and this is different from one system to another. And this refers to what's so-called big Indian and little Indian architectures, where the low bytes go and where the high bytes go. So for example, in the little Indian architecture, low bytes go to low addresses, and high bytes goes to higher addresses, whereas in big endians it's the opposite. High bytes go to low addresses and low bytes goes to high addresses. So we have to be careful when we access, especially when we transfer data from one location to another. But for us in here, X is a variable and it occupies 2 consecutive locations in the memory. And in that location, we have already put or assigned a value of 100. For example, short Y 00, that means these 2 bytes have been reserved. So these 2 addresses have been reserved for variable Y, and I've already assigned a value of 0. So a value of 0 is stored at these 2 locations. Integer, for example, in C, it occupies 4 consecutive bytes. So I reserve 4 bytes starting from this address up to this address from 4 to 7. And in this example, I have assigned a value of 2004 for the variable I. So 2004 has been stored in these 4 consecutive bytes. The character in C occupies just 1 byte. So if I say CH equals to A, character A, then I'm reserving 1 byte in the memory addressed by this, and the value stored in there is the character A. And we all know that characters are stored in ASCII code, and you all know, I assume, what's ASCII code. I can define sometimes a string of characters, and the string is nothing but an array of characters. In this example, I have defined the array called line, which has up to 6 characters as a max, and line is actually, as we're going to see in a few minutes, line is a pointer that points to the first entry in that little array called line. In this assignment statement in here, I'm saying line equals to hello. So hello is, as we can see, 5 characters in here, but they're stored as 6 characters because, as you all know, in C there is always a very last character that's appended to every string we enter, which is the /0. And we have talked about this. This is basically the null character we have talked about in the previous lecture. So the hello then is stored from the first character to the last character, then followed by this line, the null character, this /0. And it occupies addresses from 09 to 14, and that's basically the 6 characters we have reserved when we made this declaration statement. So basically, these are the addresses, and basically these are used as tags or indices to the memory. And these are actually my variables that I have declared already using the reserved words short, integer, character, or a character array like this. Okay? So when I store anything in the memory, then I have to define 2 things, as a matter of fact. The first is the address to where this data is going to go when I store it in the memory. And then the values that I'm going to assign to these variables, and that's what goes physically to the memory and stored like this. So these are my values, and these are the addresses pointing to these values. So anytime in my program I want to access any of the variables I define in my C language statements like these, that's the physical interpretation of these declarations. An address and a value which is physically stored at that particular address. And that's very much what we're saying. That's how we make an assignment. Given that I have this at the beginning of my C program, and now in the middle of my program, I said x equals to 100. That 100 is going to fly somehow and saved inside the memory at the specified address when I declared my variable x. Same thing for y and other variables that I have declared. Pointers. What are pointers? And this is the main topic we're going to talk about in this class, as a matter of fact. Pointer basically is an address. So instead of talking to the variables that I define at the beginning of my program as values, I'm going to talk about them as addresses. And whenever I refer to that variable, I'm going to refer to the address of that actually variable in the memory. So we have to be a little bit careful when dealing with these pointers, as we're going to see. A pointer is a variable that can store an address of a variable. So for example, this number 112304 is actually the address. And that's pretty much what we have talked about a second ago. So here's my memory, and here's where physically I put the data according to my variables. And then I said something like integer x. So integer x, actually, the computer is going to reserve 2 consecutive bytes for this variable x, and a pointer here, or an address, is going to be assigned to refer to this variable. However, when I say x, x refers actually to the actual content in here. So the 11 in here, if I go back, the 112304 is not the value of x, but rather it's the pointer or the address where x is going to be stored. So going back here, that's where the pointer is, PTR I'm going to call it. Okay? So PTR is an address or a pointer that points to the location where x is going to be stored in here. So we say that a pointer points to a variable that's stored at that particular address. The pointer itself usually occupies 4 bytes, and this is very important to remember. Regardless of what's the type of the pointer we're going to define, actually it's always as a value, it's always 4 bytes long. And that refers to the big number we're talking about in here. So the variable in here is always actually 4 bytes long. Okay? Regardless, whether I'm talking about an integer, a character, a double, whatever variable I define, I always point to it using 4 bytes, and that has to do with the size of the memory or the address space of the microprocessor system I'm talking about. And this is very efficient way of accessing actual memory locations, because when the variables have different sizes in here, then I'm going to be talking about different quantities, 1 byte, 2 bytes, 4 bytes, and so forth. And especially when we get to arrays, it could refer to a 1 kilobyte and so forth. So instead of dealing with variable sizes in here, I'm going to always refer to that using a variable that's fixed, which is just 4 bytes long. And that 4 byte long is actually what's called a pointer. And that pointer could actually point to a 1 byte, 2 bytes, up to this big number of bytes, like 4 gig. How to declare a pointer? Well, when we say integer x in here, actually we're defining a value called x, variable called x, and we're going to assign a value to that. So based on how this x is defined, whether it's integer, whether it's character, or something else, then number of bytes are going to be reserved accordingly in the memory. However, to define a pointer in C, we use the asterisk, the star in here. How to do that? I say, instead of just saying integer x, I would say something like integer asterisk p. So p in here is not an integer, actually. It's a pointer, an address in the memory to a variable of type integer. So p is a pointer to an integer. That's how we say it in C. When I say car asterisk PTR, PTR here is a 4 byte long pointer to a character, which is 1 byte, of course. So whether I define this as a pointer to integer, a pointer to a character, in both cases, this PTR and P, they are 4 bytes long. However, they refer to different sizes in memory, to different number of consecutive bytes in the memory. In this case, they point to 2 consecutive characters, and in this case, they're pointing to just 1. This example down here, float asterisk fp, and this float, of course, has to be small f. This is a typo in here. Okay, so p is a pointer to a floating point number, and floating point numbers in C are stored as 4 bytes. So this fp is a 4-byte pointer that points to a 4 consecutive bytes in the memory, and the starting address of these is stored in this fp variable. All right, so here's the picture. This actually is the address we're talking about. So when I say in here, integer I is a variable of type integer, and it occupies 4 consecutive bytes in the memory, and I refers to the value stored in there. Okay? The address of I is this. And of course, since it's 4 bytes, it covers this, 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 and this. However, when I say something like integer asterisk p, then in here, I'm defining a pointer of type integer. So p, as a matter of fact, equals to this number, the 112304. That's the value of p. It's the address of these 4 consecutive locations, actually the first byte within these 4 consecutive locations. All right? So in here we're saying a 4-byte location in memory that contains the address of an integer in memory. So after that, if I assign p to point to I, then what I'm going to store in here actually is the address of I. And that's why what goes here actually is the address of this variable called I, which is the 112300. Okay? So p, in that case, equals to 112300 rather than 2004. And here's the trick, and here's the point in the whole thing. More on declaring pointers. In C, we can specify the type of variable a pointer points to. So we say integer asterisk AD. AD is a pointer, 4-byte address that points to an integer. So later on, I can store at this location whatever value I like for that integer. Car star is. Again, is a 4-byte address or pointer that points to a 1-byte location, which is going to be called s. Float asterisk fp. Fp is a pointer to a floating point number. So this is a 4-byte address that points to 4 consecutive bytes, and these 4 consecutive bytes, as a matter of fact, are going to contain later on, once we make an assignment, any floating point or real number. Same thing for the s. However, in here, when I define something like car asterisk asterisk s, this is something new. Well, it's not that new actually, it's very easy, straightforward. When I say something like asterisk asterisk s is a pointer to a variable of type pointer that points to the character s. So let me go to the paper in here. Here's the memory. And I have locations like these. When I say something like asterisk asterisk s, right, I have an address here, a pointer here, okay, which is 4 bytes long. The contents in here is actually an address to another pointer. And whatever I have in here is actually the physical address of the variable s, which is going to contain the character s. We're going to see some of this in the coming few slides. Let's see some operations with these pointers. What we can do with pointers? Well, we can do everything could be done with even fixed values or data. We can assign an address to a pointer. Let's say I have defined already 2 pointers of type integer, P1 and P2. So these 2 are addresses or pointers to integers. And in my program, I have defined 2 variables of type integer named a and b. Then I can say something like this. P1 equals to this and a. What does this mean? This means P1 is going to point to a, or P1 equals to the address of a. So when I use this character, I refer to the address of whatever variable comes after that. So that's how we go from defining something like this and defining a variable like this. So I cannot say P1 equals to a. This is wrong, because this refers to an address, while this refers to the variable, to the content at that address. So to make the assignment, I will say something like, let P1 points to where a is stored in the memory. Or I can assign pointers to each other. I can make P2 pointer 2, which is another pointer which we already defined in the previous slide, to equal to this pointer, which has already been assigned to point to a. What does that mean? Well, this means that P2 is going to point to this wherever P1 is already pointing. So I can refer to the data stored in memory by using these two addresses, these two pointers. I can change the data in there by referring to address P1 or to address P2. They're equal. They're both pointing to the same thing, to the same physical location in the memory. Or we can dereference pointers. I can say asterisk P1 equals 3. Oh, this is a new thing too. Well, when I say asterisk P1, that means the data pointed by P1 is 3. So that means go to this location in the memory and place 3 in there. So this is the same as saying a equals 3, because on the previous slide we said something like P1 equals the address of a. When we said something like this, we said on the previous slide something like this. We said P1 equals to the address of a. And now I can say something like a equals 3. We all know this, simple C. Or I can put 3 in a in a different way. I can say the contents of P1 is 3. These two statements are actually equivalent. Okay? And that's what this statement says. Or better yet, I can load b, variable b, with whatever contained at this address. So I can say something like b equals to whatever data stored at P1. And this is the same as b equals to a. Okay? Okay, we have introduced this. We have introduced this. How to use them. What operations can be defined on the asterisk and operators. Okay, here's the picture of the memory. Consecutive locations, addresses down here, consecutive addresses. In my program, I have made declarations like these. Integer a, and that reserves 4 consecutive bytes in the memory for a. In here, I have reserved these 4 bytes and called them b. So b will refer to the content of these 4 consecutive locations. Same thing in here. But in here, I'm defining a variable. So whatever I'm going to have in here actually is the address that P1 is pointing to, rather than having the actual value I'm storing in here. Same thing for the pointer P2. Okay, what can I do in here? Well, I can say something like a equals to 2004. The value of the variable a equals to 2004. In that case, this 2004 is going to go and stored in these 4 consecutive locations, which we already reserved for the variable a. Okay? Very simple. This is straightforward. I can say something like P1 equals to the address of A. That way, I'm making pointer P1 to point to the reserved location called A. This is the reserved location for A. Actually, the address of A is the 112300. And when I put a statement like this, P1 equals to the address of A, then this location in here, these 4 bytes, which I refer to as pointer P1, okay, are going to contain the address of the variable A. The address of variable A is the 112300. Of course, needless to say that variable A actually occupies 4 consecutive addresses from 0 to 1, 2, and 3. Actually, I can refer to the whole quantity when I just refer to the first address. And when I read 4 bytes, it goes from that address and reads 4 consecutive bytes. So when I make this assignment, actually, what I'm doing, I'm putting in these 4 consecutive locations the starting address of the variable A. And that's why I have 112300, which is this address. So I did not put the value of A, but rather the address of A. And that's the difference. That's what we call a pointer to A. I can now change the value of A in a statement without mentioning A at all. I can say something like asterisk P1 equals to 2005. That means go to where P1 points, change the data in there, whatever the data is, and put 2005 in there. Okay, so by doing this assignment in here actually changed the contents pointed by P1 rather than changing P1 itself. So P1 still points to the same location. However, whatever I have in that location has been changed to 2005. Let me put it this way. Now, here's the memory. And here's where P1 is pointing. I had some data in there. Okay, and now when I say something like asterisk P1 equals to 2005, then what I'm doing, I'm putting 2005 in this location. However, if I say something like P1 equals to 2005, then actually I'm changing the address pointed by P1. So instead of P1 pointing to this location, P1 is going somewhere else up in the memory, and it's pointing now to this location, which is the 2005, which is not what we want to do. And there is a big difference between the two, and I want you to be very careful when you're doing this. So this is wrong. That's not what we want. This is, as a syntax, this is correct in C. However, what we want is not exactly this. We want to put 2005 in the memory at this location, which is P1, and I don't want to change where that pointer is pointing to actually in the memory. And that's the big difference between the two. So what I have in here then is the address of this location, and in this assignment I have placed this value. If I do something like this one, then actually I'm going to be changing this one, and it's going to go point to somewhere else, and that's not as what we want, as I said. Okay, let's see what we can do. When I say something like B equals to asterisk P1, okay? Actually, what I'm doing in here, I'm changing the content of location B so that it contains whatever data pointed by P1. That's pretty much like copying the content in here and placing it in here. And this is in C equivalent to saying something like B equals to A. So this statement, as a matter of fact, is equivalent to saying something like B equals to the address to the data contained at P1. So these two statements are equivalent in C. However, in this statement, we're referring to the contents, A and B. However, in here, referring to the same data, but using the pointer P1 or the address of the data pointed by P1. So the statement then in here is just going to copy the content of the memory at this location to this new location. As we all know, copying the data doesn't mean that the data in the original address is going to be destroyed. So it's just a copy of the data to the new location. All right. What can I do more? Well, all operations basically, any statement, any valid statement in C which we perform on variables can be performed using pointers. For example, I can increment the content of this location. So I can say something like asterisk P1 between two parentheses plus plus. That means increment whatever data pointed by variable P1. And the parentheses here are very important. Don't forget them because of the precedence issue, and you have covered this in the Informatics 1 course in the basics of C language. All right? So I have to say, to put parentheses around the star P1 thing to make sure that what I'm doing is incrementing the data inside this location rather than incrementing this variable and messing up the memory, as a matter of fact. So when I do this, the value in here is going to be 2006 rather than 2005, which was there a second ago before we do this. Okay? However, when I do this, of course, this location is not going to be altered. It's not going to be changed because simply I did not touch this location. Okay? So I have to put the parentheses, and I have to say parentheses, parentheses, star P1 plus plus or whatever. Or I can say like star P1 plus 5, let's say. All right? Like P1 equals, okay, excuse me. I can say something like star P1 plus equal 5. Let me put it that way. That means go to that location, okay, and whatever in there, add 5 to it. So after I execute this statement then, what I'm going to have at this location is actually 2004 plus 5, and that's 2009. So P1 is going to be pointing to data 2009. And any other statement, any other valid statement actually in C can be performed using the variable star P1 or the pointer P1. Okay? This is actually equivalent to saying something like A plus equal 5. That's like adding 5 to the contents of variable A. Okay, let's use this character and see what does it do. Actually, when I say P2 equals to the address, as we say it, address of B, that means make pointer 2 pointing to variable B. And that means go to the P2, to this location in the memory, and fill in there the address of variable B. So after executing this statement, what I'm going to have in here is the starting address actually of this variable B, which is the 112304. Okay? To whereas if I say something like P2 equals to B, that means P2 is going to be pointing somewhere else in the memory, all right, pointing to address 2005, and that's, again, not what we want, but rather we want P2 to point to the location called B and not to any other location as it might be. Okay? So that's how we use this then. I can say something like P1 equals P2. That means I don't want P1 to point anymore to this location. I don't want P1 to point to A, but rather I want it to point to B now. That's fine. In that case, this location, this variable b with whatever data in it, can be referred to now using either pointer 2 or pointer 1, p2 or p1. So these two variables now, p1 and p2, are actually pointing to the same location. And we have to be very careful when we do this, because anytime now in the middle of your program, when you change the data by referring to it using P1, you have to make sure that you're aware that P2 is pointing to the new data now, because physically you're pointing to the same location, and that location can be referred to either using P1 or P2. If I say something like now, asterisk P1 equals to 0, then I'm putting a 0 at the location in memory pointed by P1. And now P1 is actually, as we know, is pointing to the variable b. So this statement is actually equivalent to something like b equals to 0. So this statement, if you like, saying asterisk P1 equals to 0, this is actually equivalent to saying b equals to 0. Because we have already made P1 to point to B from the previous slide. So saying this is equivalent to saying this, putting a 0 in the location pointed by pointer P1, and that's actually the variable B. I can say something like A equals to whatever data pointed by P2 plus 100. Fine, this is a valid C statement. It says, assign a new value to the variable A. That new value is whatever contained at this location, add 100 to it. So it's a 0 plus 100, so this value is going to be 100. Any valid statement can be used, as a matter of fact, although care has to be used when we use the asterisk and operator. This refers to value, and this refers to address. So that's pretty much covers the basics of pointers. We're going to talk more about pointers in the coming class. You can exercise as well, if you like, on using the pointers and try these examples and any other examples you like. Of course, you can always refer to the internet, to the UNINETTUno website, and you can click on the Midnight U for further examples and exercises. Thank you very much, and I'll see you in the coming class, and we're going to talk more about pointers.